Imagine if you lived in a world where rain fell without stopping, not for mere days or months, but for endless years. Imagine the sky opening its gates and never closing them, transforming the earth you know into a world drowned in water and constant humidity. This is not just science fiction or a passing nightmare. It is a reality that actually occurred on our planet millions of years ago. This intense and continuous rainfall lasted for an almost unbelievable span of time, with rain pouring down for a full 2 million years. This astonishing event was not a minor change in weather conditions, but a decisive turning point in the history of life on Earth. The greatest surprise is not only the length of the rainfall, but the extraordinary consequences it left behind. When it finally stopped, this rainy era led to the extinction of entire groups of dominant creatures, paving the way for the emergence of new masters of the world. It is the forgotten story of the event that shaped the world as we know it and prepared the stage for dinosaurs to rule the Earth for millions of years. Let us travel back in time, specifically to more than 250 million years ago, when the Earth was a completely different place from what it is today. At that time, the world was unbearably hot, with ocean temperatures rising until they were as warm as a hot bathtub. There were no separate continents as we see today. Instead, all land masses were fused together into one gigantic supercontinent, stretching from pole to pole. This supercontinent, known as Pangaea, was a harsh world dominated almost entirely by heat and drought. Massive volcanoes had pumped enormous amounts of carbon dioxide into the atmosphere, leading to severe global warming. As a result, the world became extremely flat and dry, and living organisms struggled to survive under these brutal conditions. This dry world was not devoid of life. It teemed with various types of reptiles and mammal ancestors that had adapted to the heat. These creatures were trying to recover and rebuild their ecosystems after the Permian mass extinction that had wiped out most life. In the early Triassic period, the Earth appeared as an endless red desert, with sparse and dry forests scattered across the landscape. Geological evidence from this era shows thick layers of red sandstone and dry soil deposits everywhere. Strikingly, there was no trace of coal swamps that had covered the world in earlier periods. The main reason for this global dryness was the shape of the supercontinent Pangaea itself, which prevented moisture from reaching the interior of the land due to the continents being joined together. Rain clouds were unable to penetrate far inland from the coasts, leaving the interior regions arid. There were also no major mountain ranges to break winds or trap clouds, making low-lying lands completely dry. Despite these harsh climatic conditions, dinosaurs already existed, but they were not yet the dominant force we usually imagine. At that time, dinosaurs were still competing for their place among other powerful reptilian groups. The dominant predators of this era belonged to a group known as the Crurataceae, crocodile-like creatures with different features. This group included animals such as pseudosuchians and phytosaurs that roamed the dry world in search of prey. For example, there was a creature called Ornithosuchus that possessed long hind legs, allowing it to stand upright and run quickly. One can imagine the terror and awe one might feel if such a creature was seen standing and running toward them. Even stranger were the rhinoceros, herbivores with parrot-like beaks and stocky lizard-like bodies. These creatures had very prominent cheekbones, giving them a unique and unusual appearance compared to other reptiles. Alongside these reptiles were the dicynodonts, which were the closest things to mammals at that distant time. All of these creatures were widespread across the world throughout much of the Triassic period. One dicynodont species, called Lystrosaurus, was so common that its fossils helped scientists prove the theory of plate tectonics. However, these animals, which had skillfully adapted to life in a dry environment, were about to face an unexpected and radical change. Their future was at stake as the global climate prepared to deliver a powerful blow that would turn everything upside down. Most of what we know today about ancient climate history comes from studying plant fossils and different types of rocks. In the early 1990s, two British geologists made a very strange discovery in rock layers dating back to this era. They found rocks that did not match the well-known image of the dry and arid Triassic climate. Instead of slowly deposited red sands, they discovered thick layers of river rocks and aquatic sediments. They also found deposits from massive lakes and clear evidence of coal swamps from the same time period. All these signs pointed to one thing only: incredibly heavy and persistent rainfall. Even more astonishing was that these traces were not confined to a single region. They began appearing everywhere, from England to the Americas, and from Palestine to other regions that were very far apart at the time. This wide distribution of evidence meant that the sudden increase in rainfall was not a local phenomenon, but a global event that covered the entire planet and changed the nature of the climate on all continents. Initially, this discovery was met with significant skepticism from other geologists who struggled to accept the idea of global rainfall. Some wondered whether these rocks were simply the result of large local floods occurring here and there. But over the next 2 decades, reports continued to emerge of unusual rocks confirming the same story. Evidence accumulated steadily, all pointing to a world growing increasingly wet and humid over time. Rocks revealed coal deposits in Austria, evidence of very ancient lakes in Italy that had not been known before, moist soils in Utah, and gigantic rivers that once flowed through China. Remarkably, all these discoveries dated back to the same narrow time window. Over time, this phenomenon became scientifically known as the Carnian Pluvial Event, often abbreviated as CPE. The name Carnian refers to the geological age within the Triassic period during which these events occurred, while pluvial simply means that the sky rained heavily for a long time. To better illustrate the scale of this event, one estimate suggests that annual rainfall in the Utah region doubled, reaching up to 4 times its normal levels. Rainfall there peaked at around 400 millimeters per year, about 55 inches, comparable to what modern temperate rainforests receive today, such as those in the Pacific Northwest. And this did not happen just once. It occurred repeatedly across the world. This was not a single massive flood that quickly ended, but a series of devastating annual floods. This harsh climatic pattern persisted almost everywhere for 2 million years without interruption. With all this water flooding the Earth, life was forced to change dramatically. One of the biggest and most important changes was the sudden and massive rise of dinosaurs in the fossil record. In rocks dating to the beginning of the Carnian Pluvial Event, dinosaurs made up only about 5% of terrestrial vertebrate fossils. By the end of the event, their proportion had skyrocketed to over 90%. This astonishing rise raises an important question. What suddenly made dinosaurs so successful? Did they possess special traits that made them better suited to this new wet world? Or did other animals simply die out, leaving the field open for dinosaurs to rule unchallenged? The secret may not lie in the rain itself, but in the enormous environmental changes the rain brought with it. Heavy rainfall led to the rapid and widespread spread of giant plants everywhere. During this period, we see the dense emergence of large conifer trees and coal-forming plants, such as an ancient group known as Bennettitales, which appeared primitive and massive in form. For herbivores, This shift in food sources was a complete game changer. Rhinoceros, for example, were widespread but had a major problem: their short stature. They could not stand on their hind legs to reach high leaves. This had been perfectly acceptable in the previous dry environment, where plants were short and close to the ground. But in the new wet forests, they found themselves in serious trouble due to the height of the trees. They could only eat small plants or rely on fallen leaves and fruits. Dicynodonts, also herbivores, faced another problem. They lacked teeth. Not only that, but they did not use gastroliths, stomach stones that help grind tough plant material used by some animals like birds. Without teeth or gastroliths, Dicynodonts struggled greatly to eat fibrous food such as wood. Fossil evidence supports this hypothesis, as fossilized droppings from these animals show that their diet consisted mainly of soft ferns with very little wood. In contrast, some herbivorous dinosaurs left behind very different fossilized droppings. These dinosaurs had teeth and gastroliths, enabling them to digest tougher and harder food. The proportion of wood in their droppings reached as high as 85%, an extremely high fiber content. As the climate became wetter, small and soft ferns rapidly disappeared, replaced by stronger plants, tall, woody conifers that Dicynodonts and Rhinoceros could not eat. As these herbivores vanished, predators were directly affected and lost their main food sources. The predatory Cruratacea found themselves without enough prey to satisfy their hunger in this changing world. Thus, dinosaurs may not have been better adapted due to superior intelligence or extraordinary strength. Rather, they may simply have been the only reptilian group that managed to survive. In other words, they were the group that could wait out the storm until conditions changed. Although we do not know exactly why rainfall benefited dinosaurs in particular, we know with certainty that their numbers increased dramatically during the Carnian Pluvial Event. While Dicynodonts, Rhinoceros, and many Cruratacea species went extinct in a relatively short time. This leaves one pressing question: what caused rain to fall for 2 million years? How did a dry, arid world suddenly transform into one submerged in water so violently and unexpectedly? The answer lies in a massive geological event that occurred around 235 million years ago, just before the rains began. A huge volcanic explosion took place in regions now known as Alaska in the United States and British Columbia in Canada. This massive volcanic episode is known today as the Wrangell eruptions, a series of devastating eruptions that did not end in days or weeks, but continued for an extremely long time. The volcanoes erupted for more than 5 million years, relentlessly spewing lava and ash. These eruptions produced a thick layer of volcanic rock up to 6 kilometers deep and released enormous amounts of carbon dioxide into the atmosphere. These gases raised global temperatures by 3 to 10 degrees Celsius. Over the long term, this was not a brief warming event, but the energy that turned the oceans into a gigantic steam engine. As water temperatures rose, evaporation accelerated dramatically, sending massive amounts of moisture into the upper atmosphere. This accumulated vapor formed something like colossal monsoon systems, powerful enough to penetrate geographical barriers. These clouds broke the drought's grip and, for the first time in millions of years, reached deep into the interior of Pangaea. This was not just rain watering the land, it was a chemical reshaping of the entire planet. Rain mixed with high concentrations of carbon dioxide became mildly acidic, beginning to erode rock surfaces. These reactions altered soil composition and increased ocean acidity, placing immense pressure on microscopic marine life. But, as is the way of nature on this planet, everything has a limit. After the 2 million years passed and volcanic activity declined, the Earth began a remarkable self-healing process to restore balance. The rain did not stop suddenly without reason. It was the result of a geological process known as silicate weathering. Rocks eroded by acidic rain acted like chemical sponges, absorbing excess carbon from the atmosphere. Floodwaters then carried this carbon to the oceans, where it was buried on the sea floor as limestone. Slowly and quietly, the atmosphere was cleansed, temperatures dropped, and the sky cleared once more. The storm ended, but the world that emerged afterward was not the same as before. This event left a legacy that we still live with and benefit from today. The conifer forests that spread due to that rainfall are the ancestors of the pine forests that now cover the northern hemisphere. During that same period, amber began appearing in large quantities, preserving ancient insects within it. Even the oceans experienced a boom in microscopic plankton that later formed a large part of the oil and gas reserves that power our modern civilization. We do not merely walk on land, once ruled by dinosaurs. We live on the remains of an ecosystem shaped by that legendary rain. Thus, the story of the Carnian Pluvial Event is not just a passing chapter in ancient history. It is a profound message reminding us that stability on this planet is temporary and change is the only constant. Dinosaurs were not the strongest at first, but they were the ones capable of seizing opportunity when conditions changed. This invites us to reflect on our present reality as we witness our own climate shifting. The Earth is a finely tuned system with its own mechanisms for recalibration and balance. No matter how long it takes, this story may have occurred 230 million years ago, but its echo still resonates in every forest and every raindrop. It is a tale of a world that collapsed to be reborn, of creatures that vanished to make way for others. In the end, the most important lesson from Earth's long history is that survival does not always belong to the strongest or the largest, but to those with the flexibility to adapt to the will of change.